Hello everyone and welcome to WEkEO for Atmosphere Monitoring workshop. My name is Daria, I'm from Novartis and today I'm here to present you a QGIS exercise which focuses on tracking wildfire smoke transport across Europe. Um, Today in this tutorial we're going to look at different WEkEO products which are available on WEkEO platform. We will look at how to download them very briefly and how to, most importantly, use them in a QGIS exercise. And this tutorial is also available in PDF format, so if you prefer to follow the step-by-step procedure by reading this procedure, you are free to do so. And in this video, we'll have a following agenda, let's say. First, I will briefly introduce you the topic. So the wildfires and the smoke from them. Then we're gonna look at the data which we're gonna use for the exercises in QGIS. And then, of course, we will look at the QGIS itself and see how we can apply this data and which and what tools, what functions and features of QGIS we can use. So let's start. And first, of course, is a brief introduction. So for the context, the context of our tutorial today is wildfires. And wildfires are natural or human-caused fires that burn through vegetations and often spread uncontrollably over large areas. They're very common in regions with dry conditions, high temperatures, and strong winds, particularly during summer months. And wildfire plays a natural role in many ecosystems. It helps to clear dead vegetation. It can promote new growth. It is still clear that extreme and frequent wildfires pose severe threats to the environment, human settlements, and air quality as well. And one of the most significant consequences of wildfires, of course, is their impact on the atmosphere. As vegetation burns, large amounts of carbon monoxide, fine particulate matter, nitrogen dioxide, and volatile organic compounds, they all are released into the air. These pollutants, can degrade air quality locally, and under favorable wind conditions, they actually can travel thousands of kilometers, affecting even more distant regions. Um, Important thing to note is that the fine particulate matter, or is how it's called PM10, we will refer to it as PM10 further. Um, it is particularly harmful as it can penetrate deep into the lungs, leading to respiratory and cardiovascular issues. And carbon monoxide, while not a primary greenhouse gas, contributes to the formation of tropospheric ozone, which can worsen air pollution. And there are many other pollutants that are produced during wildfire events. And of course, during this tutorial, we're not going to look at all of them. I am sorry. Something is happening with my Microsoft Outlook tries to connect. Well, I'm so sorry. I will pause here and come back to you when I solve this problem. I'm truly sorry. I don't know what happened to my Microsoft account. Getting back to what we're talking about, and we're talking about that um, there are, of course, many other pollutants that can be produced during wildfire events, and we are not going to look at all of them. We're not going to talk about all of them because it's a very complicated matter to discuss. So, yes, just that. You have a carbon monoxide, as I said, and particulate matter, PM10, are very quite common representative of pollutants from wildfires. And as wildfires are very common in many regions, we're gonna look specifically at European wildfires and most importantly at the European 2022 wildfire events, since this year, 2022, during summer months, many wildfires took place. You can see here on a slide. You can see in red there are zones that were particularly affected by wildfires. So, um, this is it for a little introduction. And let's now look um, at the data. At the data we gonna at the data we're gonna use. And oh, this data is available on WEkEO platform, of course. So to have access to it, you have to register in the WEkEO platform, and this is quite easy to do. You just create your own account, and then you have credentials, so you can access any data on the platform in a viewer, and you can download it. So yes, you're not restricted in that. So for the products we're gonna use three products from WEkEO platform, and one of them is CAMS European Air Quality Reanalysis. In this, from this exact product, as it's air quality reanalysis, we exactly gonna use such variables as well the carbon monoxide, as I already said, and PM10, so fine particulate matter. Next one is, yeah, I'm not gonna say in details, like talk about all the details of a product because it will take a lot of time. All the links, well, first of all, the data which you're gonna use, it's gonna be provided to you with the QGIS project and with PDF procedure as well. And also in this PDF file, there are links for this product if you want to download it separately for yourself, or if you want to change time time resolution, or choose another region, for example. So another project we're going to use is this burnt area 2019, since 2019 till present time, um, raster data with 300 meters resolution. This is basically the areas that have been burned in, yeah, like um, with basically the results of wildfires. Well, not only wildfires, but them including. And the last but not least is, of course, ERA5 land hourly data. From there, which we're gonna we're gonna use only the wind. Yes, so we're only gonna have wind variable from this product, which is, if I'm not mistaken, yeah, it's two directional components of a wind. So eastward and northward components, if I'm not mistaken. So for this, we are done for this part, and let's go to QGIS and start our tutorial, the main part of it. So you open QGIS, and when you open it, the new project, it's usually empty. So let's add our background layer so it's more representative. We go to Layer tab, Add Layer, and add XYZ layer. In here, you can um, choose different background layers. And for example, since I use often QGIS, I already have a layer like preloaded for each new QGIS project. But if you don't have one, you just click on New, you give it a name, you give the URL, and these links are also given in a PDF file. So there could be different types of layers. We provide some of them. And we use Google Satellite Hybrid. So it basically looks like in Google Maps, you will see. Yeah, click on add and close, and yeah, that's basically how it looks like. We're gonna zoom more or less in European region, and we will start with exploring our data. So as I said, we have three different products to explore, but we're gonna have more files, more NetCDF files than just three. So for our first product exploration, we're actually gonna start from um, more like post factum. So we're gonna first look at the burnt areas. So to spot the wildfire events, and then from the burnt areas, we're gonna proceed to analyzing the atmosphere quality, air quality part of exercise. So, first, as I said, burnt areas. And well, burnt areas are surfaces which have been sufficiently affected by fire, and they are detected because they display significant change in vegetation cover. So it could be, well, destruction of vegetation itself, dry material, or it also could be loss of green material. And since we are focusing specifically on European 2022 wildfires, we will work with the data available for two, well, notoriously hottest months in a year. So we're going to look at July and August, and then we'll see if we can spot um, something very, well, something specific, specific events during these 2 months. So first, let's add our data for these 2 months in 2022. So we first go to layer, as we already did just before, to add a background layer, and we go to add layer, and we go to add raster layer. Here in a source, we're gonna browse to data, and for example, you will be given a folder like with data with all the um, with the whole tutorial, something like this, and there's gonna be a data folder with many files, and we're gonna browse and choose a burnt area, which we have two. We have July 2022 and August 2022. So let's select them. We can even select them both by holding Control, for example. You can see there added, two of them. You can click on add and then close. So now we have two new layers appeared here in our tab. And well, you see that it's looking very strange, black with some white dots. And that's how it's supposed to be. These layers actually have global coverage. If you unzoom, you will see that it actually covers the whole planet, which actually can take a lot of time and can be a bit bulky. And we will perform next some adjustments to make it less bulky and also to help us um, visualize the data better. And yeah, I'm not gonna zoom too much out. And what I want to say also, but yeah, you see that we have black and white layers, and in black it's basically all the background, let's say, and in white we have explicitly our bird area. So we're interested only in the white part. So let's um, tune, let's play a bit, let's say, with our layers to have better representation. So let's start with July. Double click on it, and we have our properties of each layer, and we go to symbology first. Um, in a symbology tab, we let's say go to our render type and change it to single band, sorry, pseudo color. In there, we will adjust, let's say the color ramp is going to be reds from light to dark. Yeah, okay. Um, label precision can be 0. We will set mode as equal interval and only choose two classes. So basically, yeah, the extremities. Um, let's click on apply. I hope it applied. And then let's go to transparency. And in transparency tab, um, we have this custom transparency option. In transparency band, we should choose, well, the only band we have. Let's apply it. And click OK. Well, okay, yes, now it's better. Don't forget to untick second layer because it actually covers and we don't see the changes. And well, you don't see much changes, but you see that the black part kind of disappeared. And if we zoom, for example, in Spain, we'll see what we want to see. Here, basically, you can see different polygons of burnt areas, which are depicted in red. And like this, we don't have our background, we only have polygons highlighted in red, which actually allows us to spot better the burnt areas. Um, what we just adjusted only one layer, and let's copy paste the style by right clicking on the layer we just changed, adjusted the style. We go to styles, copy style, and then we highlight the second one, styles, paste style. And if you tick it, you can see that actually here you can see more polygons that appeared. So now we have two layers with burnt areas with adjusted styles for our better representation. Since, as I said, it has a global coverage, so if I zoom out and like zoom in America, for example, we're supposed to see the burnt areas. Oh, probably it was a bad idea because it's well, these layers are quite heavy, so it actually can of yeah, it can slow down our process. So let's not do that and go back to Europe, our region of interest. So what we want to do is we want to now clip our layers so they are really adjusted to the let's say zone of interest to Europe. So for that we go to raster tab, extraction, clip raster by extent. We will choose first one, burnt area for July, and as it's clipping extent, uh, you can calculate it from layer, you can use map canvas extent, draw on canvas, whatever. I have already an extent provided. It's also provided in a PDF format, a PDF file of this tutorial. I have it like this. And do I need to have some additional? No, I think it's okay. Okay, now I can save a file. Uh, the new produce layer to a separate file, and I do encourage you to save each of layers you produce because as soon as you close QGIS, means that all the layers that you produced and didn't save in file, they're gonna disappear. So next time you're gonna open your project, even if you save the project, you're gonna open the project and it will have layers what's been saved and they're gonna be there. You can display them, you can work with them, and the layers that you haven't saved but just did them like in a temporary file, like in temporary memory, they of course will disappear. So if you want all your you want to have all your results, of course save them. I'm not going to do that because, well, just to save time, but I encourage you to do so. So now we have our new layer, right, which is clipped, and uh, let me unzoom it. So it was clipped to this specific region. And as you see, it has exactly the same representation like our layers were initially before we adjusted them. So um, we're gonna adjust them by copy pasting the style as before. But first, that was 2000. Yes, that was sorry, it was July, right? So let's repeat for the second one. Okay, now we can close and we copy the style and paste it here. We're gonna work with these two layers further, and so we can actually recognize them. Let's probably rename them. So, for example, this one should be August, if I'm not mistaken. Yes, so this one is August. Let's rename layer, but we just Ctrl Okay, and we rename this layer. It's going to be burnt area 2022-08 clip. And for this one, we will rename it. It was July and also clip. Perfect. Now we have our clipped layers. So now, um, from these layers, we want to spot the most, let's say, significantly damaged zones, right? To see, to use it after to spot the air pollution as well. And for that, what would be the easiest way? Of course, you can just zoom and see some region, see some zone, and say, okay, this one looks interesting. I'm going to focus on that. That's actually how you can do it, and maybe perform exactly the same tutorial, but not repeating after me with the zone, but finding some other areas. But what we're going to do is we're going to try to find those zones by, well, by the area. So we need to calculate the area of such zones. And to calculate the area, we need to have our layers in vector format because now it's just raster, it's a pixels, and now we want to have it like polygons. And um, we can do so by the tool that's called polygonize, but first we need to prepare our raster layers by assigning each pixel value either 0, which would make like background, so normal ground, normal whatever, and 1 for burnt areas. So for this, we go to our processing toolbox. If you don't have it open, it's a real gear um, icon here. You click on it, and let's search for raster calculator, and it's here under raster analysis. Double click, and we need to basically set an expression to which we're going to say, okay, if it's 0, then it's one value. If it's 1, then it's another value. So basically, yeah, um, so it's like binary, right? We're going to use the clipped one. It's this, for example. And the expression is simple. Our region, oh, sorry, our layer more than 0. Um, we need to set a reference layer, and reference layer is the same one which we're gonna use in expression. And for CRS, the Coordinate Reference System, we're gonna use the project one. Again, you can save it or not, but let me save it so we don't have to rename our files every time. I prepared a little folder for that, and I'll name it as I already named it before. So it's a burnt area, clipped, and it's rescaled because now we're going to have only 2 values. We run. Is it gonna? Okay, yeah, it might take some time. So yes, I probably not gonna wait here. I will pause this video to save your time, and then I'll come back to you. And important note is also that we not only need to do that for 2000, oh sorry, for July, but also for August. I'm gonna do it for both and come back to you. So I am back with you, and yeah, it took some time for both of layers, but they've been generated, and now you can see that they basically are the same as the previous ones. Again, black and white. The only thing is now they are scaled um, to 2 values from 0 to 1. And well, now we can proceed to our vectorizing process. So for this, we go to raster, conversion polygonize, this one from raster to vector. And well, now we work with our rescaled ones. So 2007 rescaled. We can save it also. I think there is only this option. Yeah, we can also save it, as I said, but I'm not gonna do that. I'm gonna just run it. And it will probably also take some time because vectorizing usually is quite a time consuming process. But Yeah, you see. But as soon as it's done, I'm doing the same with another layer, because this one I did with which one? With July, and I need to repeat the same procedure for August. Um, yeah, so let me again pause for a second and I'll come back to you again. So the polygonization process has finished, and now we have two new layers here, which is basically a lot of polygons, including as before background and burnt areas. We would be interested only in burnt areas, so we're gonna conditionally filter our layers. But first, we want to merge these two layers in one, so have one single one for the period of July, August together. And also a note, when you don't save them to file and you don't give them a name to save, it's going to be saved by some basic name. And what I'm going to do, I already did one layer. I also will rename it so it's easier for us to manipulate them later. So that's it. And now what we can do is to merge them, as I said, to have one single layer. And for that, we go again to our processing toolbox here, and we will search for, well, merge like this. And we have merge vector layers function. As we have only two vector layers in this project right now, we select them. Choose the project CRS as the project CRS, and let's again not run it, not save it, sorry, but run. Merged, and let's rename it quickly. Um, let's just say it's burn area vector because we don't have July and August separately now. And now we can filter it. And to filter it, we right click on it. There is a filter option here. And we have our um, value, the attribute in these polygons, in this layer, which corresponds to value, is called dn by default, and it should be equal to 1. We click on OK. Let's, it's not very, not very popping, the color, so I'll just briefly change it by double clicking on it and choosing, for example, red. Apply. Okay, great. Now it's more noticeable and also kind of easy to spot. So, and the main point is that now you see that, for example, it is a combination of our two previous layers. So, as we have this layer now, if you go to attribute table, right click on it and open attribute table, you'll see this table with all the data about it. So it has an ID, it has a well, DN, which is a value basically, which means 0 non-burn areas, 1 for burn areas, then the layer it belongs to, and a path. But we want now to compute the area, right? Because I told you that that's how we're going to spot our major, our wildfires of interest. So first, well, to compute it, we need to add basically the new column into the table, and we first need to go to editing mode, this little pencil here. And then there's this icon, open field calculator, like this. We open it, and in a new window, we will create a new field. We will call it area. We will put a decimal number, and we will set an expression. And to set an expression, we will search for it here, area. Or we can also like set it by ourselves, or from choosing some proposed ones. I will choose this one specifically because this one will show us area in square kilometers. I click on OK. It already gave me some preview actually. And there's a new column now added. It's called area with values calculated. So if we click on area here, see, up, wait, yes. Um, you click on the area basically. Let us actually first click on the pencil again, save it, and we click on the area again, and it will be sorted by the um, sorted by the area, so from biggest to smallest because we're more interested in it. And now to spot these features, these polygons, we can right click on a feature, for example, and go to zoom to feature. And or also, which is sometimes helpful, you can right click and flash feature and it will be flashed. So here we have some zone which is interesting, bizarre shape, bizarre spreading, but quite big in an area. But well, you're welcome to explore this map. You welcome to explore the features, the different polygons and different zones. But we're gonna focus on specific ones which we found more interesting and easier to, I don't know, to study, and we have data for it. So I think that is the feature, this one with this ID. If we zoom to it, yes, great, this zone. Um, it has what 350 square kilometers, and it is in Spain. It is in Spain, and more precisely, it is in Zamora region in here, close to border with Portugal. And where is it? Up. So it's going to be our first zone of interest, and the second zone of interest is going to be our two features actually. They're quite close to each other, and uh, what is this? This one, I think. Sorry. Oh, zoom to feature. Oh, it's a bit too zoomed actually. And this is a zone in France, in Gironde region. Um, and it's actually two. Oh, sorry. It's actually two features. This one is one polygon. This one is another. They're kind of connected, and we're gonna focus on these two regions. So Zamora region in Spain and Gironde region in France. So now, as we spotted our areas of interest, we can move on to next exercise. And now we're gonna exactly look at air pollution from wildfires, so carbon monoxide and PM10 wildfires variable. So we will look at these two variables together. Well, to estimate the potential impact of wildfires on atmosphere. And both of them, the carbon monoxide and PM10, are key atmospheric traces of wildfire activity. So, carbon monoxide is a gas which is produced by incomplete combustion, making a strong indicator of active burning or um, long-range smoke transport. And PM10 consists of fine particulate matter, which could be represented as ash and soot, for example. And yeah, these particles were directly emitted by fires, and they remain suspended in the air, and of course they affect air quality. So we're gonna assess them together, and analyzing them together, we can determine whether these variables are useful in wildfire detection, both well together and separately. And later we will see in a third exercise, we will also look at wind direction patterns, so to see how these two variables, these two pollutants, actually spread in the air. Um, so these files, these products containing these two pollutants, they are actually also given in data, and they are separate four files. So two files for PM10 and two files for carbon monoxide. So it means that we need to add them one by one. And we do it the same as we did before for burnt areas. We go to layer, add raster layer, and um, we browse to data, and we have our carbon monoxide 2078. Okay, we choose two, and PM wildfire. It's called, so it's for PM10. We choose them all, we add them, and then we close. But very important note while it's loading, it's also very heavy files. They are very heavy. They are containing a lot of information in it, and you will see it later. Ah, yeah, it's finished. Great. And so basically, since now the processing of this project, of this exercise, is going to be a bit more slow. Actually, much more slow. Maybe it's going to be better on your side with your computer. I don't know, but it might be time consuming. Why? Is because if we look at each of these files now, um, let's zoom in one of them. For example, um, oh, yeah. You see, when I'm zooming to layer, you see this picture, which is very strange. Don't really understand what's happening. And we need first to tune the style, to tune the representation of these layers, because for now we don't understand what actually is happening. But what we can see already is that it has several bands. Let's click on the first one. It's PM wildfire, or no, let's start with monoxide, carbon monoxide. Double click on it. Yeah, that's where it's gonna get a bit slow. So while it's loading, I can tell you that each of these files, it's one file for the whole month, right? So it has many bands, and each band represents an hour from the corresponding month. So yeah, it means that, for example, band 1, or like 001, I think it's going to be called, um, represents, what is it? It's going to be 1 a.m. on July or August 1st. Well, if it's filed for July, it means that band 001 is 1 a.m. to for July 1st, and if it's, well, for August, layer for August is going to be 1 a.m. on August 1st. And another example, for example, I don't know what did I write? So to give you, yeah, for example, band 466 is specifically 10 a.m. on July or August 19th. So yeah, that's not very, that interpretation is not very user-friendly, we can say, and bulky, in fact, very heavy to process, especially, well, you can see that yeah, my QGIS is a bit tired of it. But well, it is the format in which your data is provided, and we will make it work for us just fine. Um, we will just need to adjust the layers first, and we will see how to work with them next. And while it is trying to load it, I will pause video. Ah, no, look, perfectly, worked perfectly. Um, so let's then adjust the style. We open the properties, right, as before. We go to symbology, and here we see that now the render type is multiband color, and you can see a lot of bands. And for example, if you click on band, you see the huge list with what, like 744 bands. That's a lot. We don't need that much, but that's what we're gonna look at, and we see how to work with. So again, we go to a single band. So the color, we choose a band, but first let's um, let's specify the properties, and then we choose a band. So we will set minimum as 70 and maximum as 400. We will use the palette as red blue, and it's not here, it's all color ramps here. Red blue, red blue, red blue, where is it? It's here. And we're gonna invert it, so it's from blue to red. Yeah, we can leave it continuous like that, I think. We can already click on apply. It probably will take some time again. And what we also need to do is we want to set the transparency of our layer, the opacity, to 70% approximately. So like this, our layer is not going to be, well, it's going to be a bit transparent, so we can see underneath our burnt areas um, to spot the regions of interest. Otherwise, we cannot actually spot it if it's going to be non-transparent, right? I'll show you what I mean. Okay, in transparency, I'll put yeah, 70%. Apply, and now uh, let's maybe just look at how it looks like. Oh, yeah, QGIS doesn't really like it, I think. Um, why is it so? Ah, it's probably because of S, no? Birth area vector. I don't know why our background layer became so, like, well, why it disappeared, basically. I need to verify that, probably just loading, but let me first check it. I think it's because it's just very heavy, and then I'll go back to you. So I am back again. Yes, I just reloaded the Google Satellite Hybrid layer. It went better already. And also, important thing is that our layers, one we loaded, the new ones for carbon monoxide and PM10, they do not have, you see, they have a little question mark, but they have no coordinate reference system set, which is also important. For this, you need to double click on it and go to set the reference, or just click on this question mark and set the zone. Wait, set the series. Okay, actually, I think it's better if you just double click on it. Yeah, visual can take some time, but yeah, unfortunately. So we will wait while it's loading, but now, for example, you already can see that um, our previous layer, so the uh, sorry, carbon monoxide for July is loaded and it is superposed with our map. And you see that it's semi-transparent as you said it did, and it's colored from blue with low carbon monoxide to red to high carbon monoxide, and we already see some very red spots in some specific places. Um, well, it's still taking some time. Let me do the same, pause the video, and come back to you. So I'm back, and now finally all the layers are set up with our project for CRS 4226. We can continue. And what I also did is I moved to another layer. So this is a PM wildfire, right? And to this we need to have the same procedure um, to adjust the style. The only thing is that min and max value is now going to be from 0 to 10. Okay, no, actually I wanted to change the transparency to 70. Apply, okay, and we want to copy this style and paste it to the second time frame for for August, and we did the same for the carbon monoxide already. So yes, perfect. Now we have these layers, and for now we're gonna have a closer look on the selected burnt areas and see the impact of the corresponding wildfires on the atmosphere. So as I said, in each of these layers, in these raster layers of wildfire and carbon monoxide, There are many bands, and each band corresponds to an hour during this month, specific month. So what I did before, I have searched for the precise dates of those wildfires. So, for example, Gironde wildfires, they broke out on July 12th, and the Zamora wildfire started on July 17th. And yeah, note how both of these events actually happened in July, which um, and it actually spanned in 1 week, which only proves our point of what um, that's this month, and specifically apparently this week was very hot in this region. So let's first look at our Spanish region of Zamora, right? We're gonna zoom a bit to this specific polygon. Um, Now we have how we're gonna look. We're gonna, as I said, we activate our burnt area layer, and we're gonna overlap it with our pollutants in the air to see um, how they correspond and how they spread. Um, but for this, now we know that it's in this specific layer in July, right? And we double click it again to open. And now we need to choose a band. So as I told you, for Zamora, it started on July 17th. And I calculated July 17th supposed to be around 408, band 408. Um, let's go. And first, let's see on the band just before the fires. So for example, for 6, let's apply and look at it. Well, they see that most of the values are kind of like bluish, so it means that there are no high concentration. Let's choose band 408. And 408, it is midnight on July 17th. Oh, and what we see is exactly um, that our layer, it shows higher carbon monoxide concentration. It became from blue to yellowish, kind of around our zone, which gives us a hint that if it's significant, if it's, well, not significant, let's say slight increase, but already like noticeably increased, we might see already detect the wildfire. So let's look at the, well, next basically band, 209, and we see how here it starts to get to red color, so it increases. 410 seems like it passed. 411 also seems to be uh, quite low values. We see some pattern that it's not very high, but with some increases, like slight increase. Like here you see in 414 it starts to increase again. 415, oh, it actually kind of spikes, you can say. 416, we see one of the peaks of the concentration, right? Now we see at 17. Oh, what we see is that it increases, and also we can see that it's kind of moves towards northeast probably, and it looks like, and we know that it's been burning here, right? So it looks like already we can see that the air pollution, specifically carbon monoxide here from wildfire, was deported a bit like towards the north by winds. We will later check if we are right or not. And let's look at some other bands. 418, we still see high concentrations, and they are again pushed away. 419, for example, is slightly better. Let's have a look for like 5 time frames more, like 425. Hmm, seems okay. Okay, what about 30? Yeah, well, actually, another one, I guess, get to its peak. Um, and so we see that we see a decrease in the concentration, right? We saw some peaks in a very red colors, but we also see the concentration going down. And we actually might look more on the time frames because we know each time frame is just 1 hour, and we might see more peaks. That's what I encourage you to do, to look yourself at the at the data to explore it, and maybe you will see that it's actually like it peaks again, very high carbon monoxide concentrations again, which might point to us to the fact that well, wildfires they are sometimes they are seem to be under control, right? The firefighters seem to take it to be able to control it, to be able to distinguish it. But of course, it might reignite again with winds, with hot weather again. A small spark had been brought by the wind from the main fire and been, I don't know, um, um, spread in our region and it started to burn again. So, of course, you might see such patterns too. And let's now look basically at the same bands, same time frames, but for the PM wildfire, PM10 wildfire variable. So again, we need which ones? We need 406, right? It was the first one. Up, we see that we could say it's quite a calm situation there, right? And let's look at 408 path. We see immediately a huge increase, right? If we look at 409, still a big one, and 110, same. You can basically see that the concentration of it peaks, and it's very high. It's very high and very constant. You can see that a lot of the big zone is affected, and it stays the same. Let's look at the one that we saw, 417. Yeah, also you see it's kind of uh, um, dispersed towards the north. Same, you see. And for example, let's look at 426 and 430. What we can see, what we can notice, first that the pattern indeed is repeated, right, for both variables. But important also observation is unlike carbon monoxide, we see that PM10 seem to be constantly high. The values seem to be constantly high throughout the event. So, for example, when we saw that after, I don't know, band 417, I think, after band 417, we saw that carbon monoxide actually started to decrease and be more like flat, let's say. We noticed that for PM10, it's still high, it's still very elevated. And that could be linked actually to the fact that PM10 particles are heavier than the carbon monoxide particles, and they can stay suspended for longer periods of time. And yeah, while carbon monoxide is a gas, right? So it disperses more quickly with atmospheric mixing, with winds, and so on. So that could be this. Also, it could be something completely different. We might need to look at additional data, sorry, provide more analysis to understand better why this happens. So this is done, and let's look at the other zone is our Gironde zone. And even now, I mean, I don't know what is this time frame what I just chose, but even now we see that with PM wildfire, we see huge pattern of this red increase in concentration, which is spread towards the ocean. And this is, well, it's actually scary because if you see how much it covers, the zone it covers is much bigger than the burnt areas itself. So we see how um, we can say small localized wildfire event, which is not small because it actually burns many square kilometers, bringing enormous damage. But how bigger the scale of air pollution from this, let's say, small, right, area of wildfire, burnt vegetation, and how big is the produced smoke and how it transports. Even now we can see it clearly. But let's focus on it. As I said, it's 12th of July. It happened 12th of July. So, um, yeah, you can see already, if you look at the carbon monoxide, you also can see the same pattern. And 12th of July, it is, the midnight is approximately 288 band. This one. And here we can see that it's, let's say, again, quite stable, but we already see that next to our polygons, we see that it increases slightly, the carbon monoxide concentration. Next band, well, let's see, even 90, 89. Yeah, you see it increases. 2090, same. Let's look on, well, 93, we see that it increases, kinda, we see that it's slightly getting reddish, more red. Okay, here we can see much more presence of a higher concentration. And on this exact band, band 296, which corresponds to approximately 7 in the morning on July 12th, we see that it starts to peak the concentration of carbon monoxide. And the following ones, we see, yes, that it rises more and more. At 300, it's quite big, and we can see actually that from this one, we also there's another polygon, which another wildfire, here in Bay of Arcachon, which also brings us more and more pollutants into the air. So 301, same. And if we see, you look at our days, we can see that it's most of them are, well, fluctuating, let's say. So sometimes it peaks, sometimes it's very red, sometimes it's less red, like here. Sometimes it comes back, like here, right? Like this, and so on. And well, these wildfires were actually, um, they took quite a long time. They were burning for a long time. So that also, like this pattern actually represents that too. And what else we should do is, of course, we can compare to our PM10 band. We started from 286, 88, I think, yeah. And yeah, you can see that it's same, getting very, very high concentrations, very red, and you can see how they are actually more merged. You see the two sources of two wildfires were kind of merging, and again, um, you see how you kind of see the pattern of the wind basically pushing it towards the ocean, and we see also how in the carbon monoxide we saw well, several pixels, let's say, right, of well, red pixels, and here we see much more pixels. So it's as I said again, uh, for PM10 we see a wider and bigger impact on air pollution. We see that it covers bigger areas, well, it spreads, which is also very important to note. Let's look again. What 312, for example, same. Well, not the same, but I mean the pattern is quite clear. So yeah, that was it for the second exercise. And now let's look at the last exercise. And this is gonna be for wind direction. As I said, we already could see from this pollution how it more or less spreads. So now let's like verify mm, our what we're supposed to see, what we assumed to see with wind vector field. So to plot wind vector field, we need two components, directional components of wind. So it's eastward direction and northward direction. And as we have these two components, we can calculate directional wind and the speed of wind. And for that, we will uh, look at the new option of a layer, a new type of layer, which is called mesh layer. So we go to layer again, add layer, and add mesh layer here. We'll browse to our Era 5 July 2022, since we know it's in July. We add it and we close. Let's drag it a bit. So now we have this as a layer, which representation is quite strange, we would say, right? It's not very clear. It's very dense with many. Um, you can, if you look very like, yeah, if you zoom, you can see that it's actually arrows on top of um, on a background, and it's kind of a lot. It's kind of too much. We don't really understand. It's not very user friendly, right? So what you're gonna do is you're gonna adjust the style again. That's very convenient. Again, double click and we go to symbology. So in symbology, it's very specific um, for this type of a layer. So let's first go to groups and let's choose a time frame which ends on 72 to zeros. 72 to zeros. This one, because this one time frame actually corresponds to July 12th. And this is our Gironde fires, right? So what you're gonna do is we need to click on this rainbow, little rainbow icon, and on a little arrow icon to activate the two components of this layer. And now we go to rainbow icon here, and we set the opacity to 0 because we are not interested in the background, we only interested in arrows. So we click on apply, and we already see how it changed, right? Let me actually zoom to our round region here and activate, I don't know, this one, for example. Let's go back. And now let's go to the arrow tab. And here to represent, like to have a better representation of our arrows, we will set the width to 1.5. And the color enough, there's not a single color. We want to color ramp. Let's choose, what's it? Is it rocket? I think it's rocket, right? Oh no, this one is rocket. And I think, yeah, we can set it like this and set min as 0 and max as 10. Mode equal interval, classes, oh, it's a lot of classes, though, let's say 5, apply, and okay. You already see how it changed. So now we see the arrows and the color of an arrow. It represents the speed of the wind, and of course the arrow points to directional wind. But what we set it for 12th of July, right? So what we need to do then, as we superimpose it with PM wildfires, right? Let's go and choose a time frame that actually corresponds to 12th of July, because 300, what is it, 316? I'm not sure 316 is actually 12th of July. No, it's already not, but if we set, for example, 200, 300, sorry, 5, I think it should be, yeah. So 305 actually corresponds to approximately 4 p.m. on July 12th. And now we can actually see that our um, if our conclusion before was right. Here we can see that wind goes from north east to southwest, and it actually pushes all of this from produced smoke from these regions, right, from burning regions towards well, towards kind of the ocean, but like to south west part. And unfortunately, as it's Era 5 land product, it only has well data for the land, so for wind direction, but over the land, so not over sea. So we cannot actually see the patterns of wind over the sea, but we already see that from the ground. We see how it actually pushes, how it actually spreads, um, um, how it actually spreads the smoke. And this product, Era 5 wind, is actually daily, so we cannot check more hour per hour. So for example, here you can see that there are only, if you count them, you can see that there are 31 bands, so for for each day. But that could be also an interesting exercise for you to find on a WEkEO platform data for Era 5 hourly. I think I think, yeah, it should be there, it should be available. And to see also more in um, in details superposition of wind direction and well, air pollutants due to wildfire events together for like hour per hour to see more um, like to see in details, more in details how it spread. So that was it. And this was it for this like third very small exercise just to see how to work with vector fields, directional fields, for example, wind fields, like here. And it's overall also done, the whole tutorial. It's been a bit long and also took some time regarding the data, loading it and then displaying it. So, what did we learn in this particular tutorial? We learned how to work mostly with raster layers. We learned how to display them, how to adjust their style, so it's more um, so it's easier to visualize them. We learned how to clip them according to extent. We rescaled them. We learned how to vectorize them. So from raster layer, obtain vector layers. We learned how to merge and conditionally filter vector layers. And what else? Yeah, we saw how to also superimpose different type of data to see, to draw some conclusions. And we also worked with a new type of layer, is a mesh layer to see vector field. So that's basically it for this tutorial. I really hope you enjoyed it and you learned something new. And as I said, don't hesitate to repeat this tutorial or to play with data which we provided for you to have um, some different results, some to learn different events maybe, to look at other areas of wildfire events, or maybe even completely different topic in which you can use the same QGIS features. Who knows, right? So yeah, feel free to explore, feel free to play around, and again, I hope you enjoyed it. I hope you learned something new, and yeah, thank you very much for your attention, and yeah, bye bye.